Cool. All right. So, what I'm going to be teaching is mastering forces, and I figured we'd try this event on Discord uh, just to see how it goes and see how many audience members we can get. Um, but overall, and hopefully the stream quality is better than on YouTube since I can stream direct to to you guys. Um, so basically, we're going to go over forces, and this should be fairly quick, maybe 30 to 40 minutes tops, to kind of go through how to use forces in Embergen and how you can kind of level up your simulations. In my opinion, forces are probably the most important thing that you can learn in Embergen. If you ever ask, how do I do this, this, and this, you can probably do it with a force, and that's probably going to solve most of your issues. So we'll go through a couple things, and I'll show a few things that we can, make with it, and it'll be fairly free flowing, which is why I'm doing a stream versus a dedicated tutorial. But we'll probably have that in the future too. But without further ado, let's go ahead and just start a new project. And we'll get my screen kind of ready here the way I like it. And so the first force, and actually what we'll do is we'll bring in kind of all of our forces here, and we're going to go over them and master them. So we'll kind of add in all these. Got a point force. We've got our vector field, which we won't cover that today because I don't have any vector fields with me. But that's fine. It's probably the most unused force that we have. But we'll cover everything else, and we'll show you some cool tips. But questions, real quick. Somebody says, any idea when skyboxes will be added so that we can import our own HDRIs in 2.0, most likely? We do have some stuff that we might add to 1.0, but I'm not completely sure. Our rendering guy, Morton, would have to answer that. But I think we were trying to do some stuff in 1.0, but it kind of didn't work out very well for us. But yeah, 2.0 for sure. So, okay, here we go. And this is probably going to be the start of the YouTube video. So, basically, we've got our first noise, which is force noise. This is probably the most important one. And if we look here inside of our sim and we turn off, say, this force noise, we can also turn off the one that's on the emitter. You'll see that we'll get just a really nice stream. And we do have like a little bit of vorticity. And so I guess this is also a type of force to some degree. So if we go to our node details and we go to forces, the most basic force is buoyancy. And we also have gravity, but by default, gravity isn't going to do anything because we don't have the smoke weight or the fuel weight set to anything. So if we turn on our smoke weight, you can see that the sim is going to start to fall to the bottom. You can also make fuel heavy as well, and it'll fall a bit faster if we drag this up. You can also see another force just happened, where whenever I drag this, the emitter is injecting force, and that's controlled by the forces tab with velocity transfer. If we turn that to 0, you'll see that nothing happens anymore. And so it's just kind of a basic thing, and the smoke is falling down. So there's a number of different force types that are always happening with your simulation. And if we go to the vorticity tab and we turn this down to 0, we should have just some really smooth smoke. And we also have these masks settings. And so we're going to get into masking too, but to kind of say it, how can I put this? Basically, masking allows you to apply certain forces to certain channels in your simulation. So a simulation has a few different channels. So you've got your temperature, which is going to make fire glow and things like that. And if you have buoyancy, that's what's going to affect the rate at which smoke rises. So if we go to our force, we turn on our buoyancy. Let's say we max it out to 250. You can see that now the smoke is actually getting sucked up because there's so much upward velocity. And one cool thing that we added in 1.0 is you can enable gizmos to see what your forces are doing. And you'll be able to see why I'm saying that if you master forces, you can master your simulation. So basically, in simple terms, if you can get your arrows to point where you want them to point, you can make anything you want. And so just imagine the sim as a bunch of arrows. And so, for instance, real quick, if we said, hey, I want to make these arrows kind of spin around, well, the way to do that is we could get a force line, and we'll grab this in. And let's go to our forces. Well, let's make our buoyancy something like 25 so that it's manageable. And then we want to create a twisting force to make this rotate. And so we have this line, it's pointing in Z, and we want to rotate this. And so we'll say we want to add a twist strength. And so now we've got kind of a tornado effect. And if we look at our lines again, or our arrows, you can see that they're rotating. What is this? Counterclockwise. If we wanted to rotate it clockwise, we could go and actually we'll leave our push strength and we'll kind of do our twist strength as negative. And that's going to be a clockwise motion. So you can kind of see it's pretty cool and it's quite intuitive. And so one neat thing is that you can enable gizmos either for your individual forces, or you can enable it for the entire simulation. The entire simulation is going to show all of your things, including buoyancy and any vorticity and things like that. And so you'll notice that the smoke right now is very smooth. The fire is very smooth. And what we can do if we want it to be more detailed, and we can turn off our visualizer for just a second. If we go to vorticity, that's basically going to kind of multiply against our smoke. And nothing's happening right now because we turned our masking off. So in this case, we can make vorticity say only on our velocity channel. We can make vorticity happen only where temperature is. We can make vorticity happen only where smoke is, and so on and so forth. And it's based on the strength of the smoke and how much density there is. So if we wanted more vorticity, we could go to our emission, increase our smoke rate, and now there's going to be more vorticity where the density is higher. So there's a lot of depth to the masking system here. And so we can just kind of reset this to our defaults, and now everything is, fairly noisy with our vorticity. So yeah, so vorticity is going to control the noise of them. And so kind of the next thing to go over is the masking of any force. And so you'll notice that each force all have the same tabs for the most part, except for this one. And what is it missing? It looks like it's missing chaos because noise is chaos. But for the most part, each force has the same tabs, which is pretty cool. So we'll go ahead and turn this this force visualizer off again, and we'll just focus on this line force for now. So in the general tab, you have a number of different things. So if you didn't know, you can turn any force on or off at any time. So you can go up here to your little on-off icon, and that's one way to turn it off. Or you can animate your activity. So you can click these little circles. That'll add anything you want to the timeline. And you can hold Shift down on the timeline and then click, and that'll add keys. And so if we go here and we say, hey, we want this line force to happen at the beginning, and then we want to turn it off, well, there you go. That's how you would animate a force. You can also animate any of the, what would you call it, like strengths of your force. So you could say, hey, I want to take my force strength, and we can go ahead and turn that off. And so just turn it on and remove it from the timeline. And then if we want to take our push strength, for instance, we can say, hey, I want it to be like 5, and then I want it to go to 0. And so it's going to push our simulation up and then animate that to 0. And you can see the value is changing there. And that's going to be a nice way to animate your forces. You can do other weird things by exposing parameters. Let's say we wanted to expose maybe our rotation to the timeline. You could do something like plug in an oscillator, and now we can view this. And we can see this line force is kind of going crazy. So we could choose, say, random noise on our oscillator here. This is going to give us some pretty random, chaotic motion. So we can see here, now our line force is doing some pretty crazy things. It's actually doing like some gimbal locking, something like that. So if we want to prevent that, we can kind of change our frequencies a little bit, maybe change the phase to give us more randomization and now our line force is just going to constantly rotate around and be random. So, and then you can move this up or whatever you want, and it'll do some crazy, crazy things. We can also increase the bounds of our simulation real quick. So we'll do something like, let's say 256 by 256. Just make this bigger so that we have more area to sim in. And you can kind of see the crazy turbulence that just this very simple thing is doing for our sim. And so if we go over here to our line force, you can see that, like I said, we're just rotating around. And if I pause this for a second, you'll notice that we have some pretty cool gizmos on your line force as well. So right now, if we decide that we want to add a push strength, you can see that we have an arrow that goes here, and then the dotted line is actually where the line force is, and it just goes to infinity. And so you can see there, it goes off into infinity. And this would affect particles and things like that too outside of the bounds, but we'll get to that in just a little bit. You've got your push strength. One other important mode though is, you do have volume and particles. And so basically what this does is it says, hey, if I have particles, I want to affect my particles as well as my volume, which is a pretty neat thing. So just real quick, if I added a simple particle emitter, and let's go ahead and make sure our particles are plugged in, and they are. And so we've got this, and we've got this little shape emitter here with particles, and we're going to go to, oh, sorry, did the wrong thing. Particles, there we go, shape. So now you can see that the force is affecting the particles. But if I go over here to my line force and I say, hey, I only want to affect my volume, the particles are still being affected. And that is because in the particles, we have an active forces tab. And we're saying we want to take about 55 to 75% of the volume's force and apply that to the particles. But if I make the volume contribution 0, now our particles aren't going to be affected at all. If we make it 100%, it will follow 100% of the volume. And then you kind of have like a range that you can say, hey, I want to follow the volume a bit and I don't. And so that kind of gives you some randomization for each of your particles individually. And then, of course, you can do crazy things with particles like inject smoke and do all kinds of other stuff. And so, for instance, if you want a very, very specific simulation or whatever, let's say we turn off our volume here and we want to make the volume contribution 0 or very near 0. And then let's say we want these particles to rotate, and you can kind of see that they are. But we can make this only affect particles. And so now the smoke will be exactly where the particles are, and you can create some pretty weird simulations that way. But we can make it more dynamic if, which is another type of force, we can go over here and inject velocity from the particles themselves, and those are going to kind of push the smoke around and whatever. And with this is just an endless depth, so we're not going to get too much into particles. We're mostly going to focus on forces as they apply to the simulation as a whole, but this is kind of a rabbit hole that you can go down. And one of the last things I'll kind of say with it is with our active forces, you can choose a force tightness. And so say if we did 100%, the particles will follow the absolute vectors of your force. So if we go over here and we look at this and we choose our visual, and looks like it is bugged for some reason. I'm not sure why. It should show the arrows. So it looks like there's a bug. Maybe it's only whenever it applies to that. So yeah, maybe if particles only are selected, it doesn't show it. So that seems like a bug. But basically you can see that the force field here is kind of rotating around. And so those particles are going to follow those vectors exactly because we have the force tightness as 100%. Now, one interesting thing, so we can go ahead and turn off those particles and we'll stop using them. They're going to just die out as their ends. So back to the volume. So we've got this crazy volume here. But in the simulation force tab, we also have a force tightness. So you can make smoke and things like that follow it just as, I guess, abruptly or whatever it happens to be. And then your smoke and stuff isn't going to diffuse as much, and you kind of have some really weird effects. And so this is really good for, say, something like chaos or whatever it happens to be. And you can see if maybe we drag this up, it could be something kind of magical. And so one thing that I'm kind of thinking of here is you can stack forces as well. So if we go over here and let's say we want to grab our noise force. And so now that we've added a little bit of noise, you can see that it's kind of changing this. And it is a bit different because we do have quite a bit of force tightness. One thing I want to mention about this should probably be mapped like 0 to 10%, because if you do 100%, it gets pretty crazy. And in a lot of cases, it doesn't look very good. So you probably want to, work within like the 0 to 10% range, but you can experiment with force tightness and just kind of see how things are. So pretty crazy. But like I said, you can kind of stack, different forces and things like that. So if we went here and say changed our noise scale, you can see how this is, reducing detail in the sim. If we lower the scale, it's going to add more frequency and subsequently give us more detail. You can also add more octaves. So if we look over here at our noise preview, as we add, more octaves, so at first it's kind of blurry. You add more octaves and it adds more noise. And so it's basically just adding, smaller and smaller, um, noise, what do you call it, like layers on top of each other as you add more octaves, which is pretty cool. You can also increase your amplitude, which is basically the strength of the noise. And then you have linearity, and it's kind of like basically the scaling of the noise. So if you look at the preview, this gives you a pretty good idea of what it's doing to the noise channel. And then you also have gain, which is kind of like a very harsh multiplier against your noise. And you kind of see it's, you could consider it as like detail or whatever. So if we kind of, take our force line and we disable that for a minute, and then we go to our visual and turn that off too. We can, view our noise as well, and you can kind of see what it's doing. It's very simple. It's just kind of adding random velocity through different pockets inside of the simulation, which is pretty cool. But force noise is really one of our most powerful noises in general, because it's a good way to add detail to a simulation. So, for instance, let's say that we want to start with maybe this default explosion or something like that. And let's say we turn off these two noises. We get something, kind of simple, and it looks pretty good. And what's actually creating a lot of this noise already is the pressure here. So if I maybe turn our pressure off, we get a very simple puff of smoke. And we do have some detail because we have our vorticity at like 25%. So if we had none at all, this is what it looks like. Then if we enable our noise, we can kind of see that it adds quite a bit of detail. And so what we're doing is we have a certain scale, and then we have, so you could say we can make it bigger or whatever. That's going to make it more chaotic. If we want it to be more of, say, a large scale explosion, we can make the scale smaller. We can also add more octaves to kind of give us more detail inside of our noise. And then we also have like an animation speed, which makes sure that the noise animates over the life of the simulation and whatnot as the sim, kind of goes on. But if you don't want to, you don't have to animate your sim. So if you want it to be just static noise and kind of do, um, you know, uh, basically affect the smoke in the same way as the smoke does its thing, that'll allow it to do that. So pretty neat. We are using masking on this, so this is another very important thing. So maybe why don't we'll go back to our default preset that has kind of a fire that goes on its own, and we can kind of demonstrate masking. So by default, I believe that the noise is just constant. So whenever it's constant, it's applying to the velocity, the temperature, and the smoke channels kind of as a whole. But one of the things is that when you apply a constant to kind of everything, it is kind of dangerous in some ways because you can get like maybe not necessarily stuck voxels, but it tends to look kind of unnatural because you're applying it to everything. And so ways to get more natural smoke is, you could do, say, something like a 10% constant, a base. But let's just say we do 0. If we take our smoke mask, now this noise, and let's make it a bit more chaotic. Let's say 10, maybe even harder. Let's do like 100 so that it's really chaotic. So basically, if we have all of our masking at 0, nothing is going to happen. And we do have kind of a noise force here, so we'll turn that off too on the emitter. And so uh, basically, if we come here again, what did I change? Okay, masking. Um, and so if we turn our smoke mask up, you can kind of see it's a multiplier against the amplitude. So this would basically be 1 times 100, and then this is, say, 0.5 times 100 as what the force is here, since our amplitude is 100 right now. And so you could also say, hey, where there's temperature, I want there to be more chaos. And so in something like Houdini, you have something that's called like a microsolver. And I believe that this is a pretty fair equivalent to that. So people, they say, hey, I made this microsolver or whatever, and it's really cool. And, it does this thing when there's a certain amount of temperature. That's pretty much what this is going to allow you to do. So if we enable our gizmo, which it looks like, again, it is not working. Um, Unfortunately. We'll have to figure out what's going on there. Seems like a bug. But hopefully it would be showing. It looks like it's probably because it's not, because we don't have any constant mask. So we'll have to fix that. But basically, if you could see the arrows here, you would really see just a bunch that are localized here to where the temperature is, and then they would kind of die off at the top. And we could probably look in the visuals tab here. And there's another mode that you can view, which is 2D. And so we can view like a 2D slice. You can see the kind of where the temperature is, it's pretty chaotic and it goes up with the buoyancy, but particularly where the fire is the hottest, that's where the velocity is the most chaotic. So it's a pretty cool way to visualize what's going on. So if we go here and let's say we really ramp our temperature up and we view this again, you can see that that's where the velocity is going to be the craziest because we're applying it to that temperature. So that's basically how masking works. And like I said, it's a really good way to add chaos to specific things, but not to others. So, in this case, maybe I want the fire to be chaotic, but I don't want the smoke to be as chaotic. So I would come in here and mask that. And so that's pretty cool to be able to have that fine-tuned control over your forces. And of course, you can add, say, if we wanted this to be more of like a raging fire or something like that. One of the weird things is that it's kind of chaotic in full 3D. It's in every single axis. And so one thing that we can do to kind of circumvent that, if we want it to be, say, a force of chaos in a certain direction, but we don't want to use a line force because we want a lot of this chaos, is you can do a bias. So we can say, hey, I want this to be biased in the Z axis. So if we do say, maybe make a constant mask or whatever for a second, you can see that more or less most of the arrows are pointing upwards more often than not. And so basically a bias is going to say, hey, I want to point my arrows in a certain direction or whatever. And we'll kind of go back to our masking, turn that down to 0 for constant. And so now, more or less the fire is going to kind of be chaotic, but it's also going to point upwards to kind of direct the fire there. We could also, use buoyancy to our benefit and say maybe make it 250. And that's going to make the fire rise pretty high as well. But you'll notice that, well, now we kind of have our turbulent forces in the global simulation, but maybe we want to mask forces specifically where the emitter is. And there's two ways to do that. So we can either apply a force directly to the emitter. So plug it into the emitter and then say, hey, we want more amplitude. Maybe we want more scale or something like that. That's going to kind of help us break up our emitter shape, add in a bit of additional force or whatever. And that's pretty cool. But one other thing you could do is say, if you wanted this force to only be localized to just the shape of the emitter, well, then you can plug in your emitter mask shape. And so now the forces are only going to be chaotic within the emitter shape. We could do something different to where, say, maybe we want a box or whatever it happens to be. And one thing we can do, one thing that I wish we had was a way to visualize shapes. But one of my favorite ways to do it right this second, just to kind of add in an emitter particles. And then that gives us a wireframe, and we'll just kind of see this real quick. And so we can say, hey, I want a box, and I want to only have my force affecting, say, this thin little area or whatever it happens to be. And now that I know where my box is, I'll go ahead and delete that. And so now the force is being masked by that box, and it's only affecting the fire within that box or whatever. So it's a good way to create very specific types of forces that are only in certain areas. So, for instance, like let's say that I wanted this area up here to be chaotic too, or maybe I want, say, a point force or something. One way to mask it is you could do, say, a linear fall off or something like that. And we could do, say, negative pressure, kind of suck in all of our smoke or whatever, if we want it to be kind of like a spaceship thruster, is one way that you could do this, which is pretty cool. Or we could say, hey, I don't want any fall off at all. I just want a mask shape. And so now where this shape is where the force is going to be affected. And so if we bring in like our little particle trick again, so that we have a wireframe, let's see, so that we have a wireframe. Let me actually emit no particles at all, just so that we have our shape. And so, actually that's the wrong one. Drag that in. And so now we have this, and so we can kind of see where our point force is going to be. And you can see that as we increase this shape, it really kind of sucks in everything or whatever. And so you don't have to do pressure. You can do like a repel strength. And so this could also push your simulation away if you want it to. And so in this case, we have this point force. And so you can kind of move this around as like a thing to kind of push your smoke or whatever. There's all kinds of weird things you can do with these forces and masking and things like that. But it doesn't have to be a point force. It could also be, say, another noise force. So you come here and let's just say we have like a really ridiculous, thing. And so we've got this up here. And so now just kind of where this shape is, it's like really, really chaotic. You could mask it to be, say, instead of constant, only on the smoke. So now it's not going to affect the fire, particularly unless there's a lot of smoke, beneath the fire or whatever. And so now we've got some pretty strong chaos there. And so now it can affect the sim. You can make it grow or whatever. So imagine, maybe you want to push smoke away from an explosion or something like that, but you only want it to last for, a couple seconds. You could grow the sphere of this radius on the timeline and have some pretty awesome chaos for a second. Or maybe you wanted to, add in additional pressure, say through a point force or something like that. You could do that, through this. So you can see there, boom, there's some additional pressure, and it's pretty crazy to just kind of come in and maybe animate that sphere radius. So pretty interesting. So I think we've mostly covered the gist of your noise force. So overall, it's a very good way to add a lot of turbulence, add in a lot of cool motion. You can do masking on the different channels. You can do a bias to push it, so it's a good way to do wind as well. So if we maybe say, looks like you can't do more than 10 for some reason. But overall, it's going to allow you to push your simulation in any particular axis or whatever, and it's pretty neat. And you could apply, say, a constant in this case, where maybe if you are doing, say you want a little bit more force or whatever in a particular axis, you probably want to apply it to the velocity channel as well, and that's going to help make sure that you get your smoke wherever you want. And in this case, it's too strong. And so we can make this a lot lower amplitude and kind of scale. And you can just kind of play back and forth with your scale, play with your amplitude and things like that. For most things, you probably don't want anything too crazy unless you have like a raging fire or something like that. And then even then, you probably want to mask it to be localized, maybe only on the initial emission you have a crazy amplitude or whatever it happens to be. Because if you affect the entire simulation, it's just not going to look too good. So that's kind of the gist of noise forces. Going back to line forces, one of the last things I'll say about it is, you have kind of a chaotic scale. And so, for instance, let's go ahead and delete this. And we've got our fire here. So chaos is kind of a built-in force noise, more or less. And you can kind of change your chaos intensity. And so it basically just says like, hey, if I have a push strength, I don't want it to be completely the same, for the whole sim. And so you can kind of see the chaos that's happening. So the push strength is just kind of changing over time, and it's animating. And if we change our chaos, scale, we can kind of see how it affects it. If we change our animation speed to say 0, you can see that it just kind of gives you different, what would you call it, magnitudes for your velocity and things like that, which is pretty cool. And you can also change like the seed of it as well, and kind of your animation speed and whatever. So pretty interesting to be able to change this and affect your line forces as well. And then we have a fall off, so you can do some pretty cool stuff with this too. So say, where if you only want the line force to affect the simulation within a certain radius from the line, it's a good way to do it. So for instance, if I bring in, say, some of my clouds from our premium preset pack, you can see here that I'm using a line force to kind of push my clouds in a certain direction. And I believe with some of my cumulonimbus clouds, I used it as like an actual wind shear, so that once the clouds get to a certain like altitude, that's when I really start to push the clouds in a certain direction. And one big thing with a lot of the clouds is, if we look at the node graph, most of the node graph is the same for them, minus shapes and different forces. So to kind of get like all the different presets, I really took the time to come in and, make sure that we have vorticals, which this is a node that we're going to go over in a second, and, kind of tweak our force noise and things like that. And then whenever you click the little dice icon at the top right, you'll notice that your seed changes on your noise. And that happens on, your vorticals as well. And so you can kind of come through here and kind of, change your vertical seed, change your noise seed. It'll change like your pressure seed and everything else, which is really, really quite cool. So forces are quite powerful. And, using your line force to push things as wind is a good thing if you don't want to use the bias trick on your force noise. And making sure that you have a fall off is a pretty cool way to do things. You can also do a line segment, which basically means that within a certain length, so within this cylinder of our line force, that's where the line force would be applied, instead of infinitely across the entirety of the simulation, which is pretty cool. So that's a neat thing that you could do. So say, for instance, if we had this cloud, but maybe there's a very specific force only in that one little area. So say if we wanted to get a bulge, on the cloud, so maybe we'll, move this over so it doesn't hit the bounds. So we just want to push this smoke over and, maybe get a bigger bulge on this side to kind of artistically direct, how our cloud is growing or whatever it happens to be. You can kind of place these forces wherever you want to just kind of, maneuver the simulation wherever you want. Maybe we wanted it to be, maybe we want to create like a bulge over here on this. Maybe we'll do like 10 as our push strength. So that's going to kind of pull the cloud in that direction to grow it where we want to grow it. And that's probably a bit too much, so we'll lower this. And so you can just kind of see how using a line segment could really help you create certain shapes in a simulation. And it's almost like sculpting. So, if we want to, we could say, hey, I want to animate this. I want to sculpt this for just a second. And now I'm going to turn my line force off. And you could animate that on your timeline. And so now you have a very specific shape and you told your simulation where to go. So this is a good way to kind of craft certain shapes, and you could do the same thing with explosions or, your fire, whatever it happens to be. And this is a good way to kind of use it kind of like a stylus, something like that, to sculpt. So pretty interesting thing. Not super intuitive as if you just came in here and actually painted your cloud, but it's a good way to kind of guide your simulations to where you want to go. You could also do kind of the reverse, to where, say, if we turned our line force the opposite way and we didn't want something to grow over there, we could kind of create a field over here. And then once the force kind of gets over there, the cloud is going to kind of resist going in that area. So we could create our thing here and make sure that it's actually on. And now the cloud is going to resist going in that bounds or whatever. So you can kind of say, hey, I don't want you to grow over here, but I do want you to do over here, whatever it happens to be. Pretty neat. So we'll go back to our default. And so let's see if there's anything else on line force to cover. Um, I don't necessarily think so. You do have, say, you're twisting and pushing and repelling, and then of course twisting is being shown, with your different lines. So you do have your main gizmo here to kind of see what's happening, and then you have a repel strength. And we don't have a gizmo for that, but basically the way to think of it is if you repel, all of your vectors are going to be pointing away from the line. So if we, have no push strength or anything, and we repel, you can see that it's kind of pushing things outwards from the simulation. And then if we, have negative repelling force, it's going to kind of suck things in. But one thing to note about the sim in general is you can see that it's not exactly doing what you would hope, where it's just kind of a constant thing. Maybe what you'd want to do is have negative pressure to actually suck in or push away from the sim. But what's happening is kind of like, I guess you would call it like a pressure issue or something like that with the simulation. So we can go in here, view our visual, and we'll change this to 2D, and we're going to view on the Z axis. You can kind of see that we kind of have basically some stuck vectors over here. And that's just because the pressure needs to equalize, with these small bounds, and it's not perfect. And because we're not simulating anything outside of the bounds, it doesn't really know what to do, and it doesn't have anywhere for the fire and stuff to go. So it's creating this kind of weird issue with our velocity. And so that's just kind of the nature of simulations. And if you want to circumvent that, you can make your bound, say, a bit bigger. And so now things are kind of, suck in kind of the right way or whatever. But it is very linear. So you can kind of see it's all the same shape all around. And then the fire has to have somewhere to escape. And so it kind of escapes through those corners. And kind of the way to circumvent that, like I said, is if you kind of come in and add maybe some actual pressure, but then that gets kind of dangerous too. And so, but hey, you can kind of create some cool effects like that. It's like the birth of a star or something. So pretty interesting things that you can do with your line forces by animating pressure and whatnot. So really quite cool. And so I think that's about it. I went over the chaos, and all the masking and stuff is the same for that. Now, one of the coolest forces, and this is the last force we'll go over, the torus is a bit difficult, so maybe I'll cover that just a little bit first. But basically, you have basically a ring, and you can kind of come in here, and it looks like, I did not know you could do that. Looks like you can change your things in the viewport if you grab the actual widget. Cool. And so, but basically, you can repel from this circular line. You can twist around the line, similar to a line force, but it's just maybe in a certain axis or whatever. But it behaves mostly like a line force does, which is pretty cool. And then you have a push strength, which pushes the simulation around this certain line or whatever it happens to be. So if you really want to, say, force a mushroom shape or something like that, this is going to allow you to force that shape. In this case, you might want to go in and have a certain force tightness. Otherwise, it might not work. And so you can have some really weird simulations here with this. And then, you could do a little bit of a twist. You can have it be twisting and kind of rotating and whatever. You can also do a little bit of repelling to kind of suck it back in towards this to create a really strong vortice or whatever. And you can move this up and down, whatever it happens to be. And this is more of one of those like sculpting things where you really want to make things do something. It looks like it's not even simulating, but it is. It's just that the force tightness is so strong, we're not allowing it to do what it wants. And so it's kind of a cool way to create some really unique shapes. This typically works a bit better if you are using a fall off, and so maybe you want to have it affect only a certain area or whatever it happens to be. And then you kind of bring this up into that shape, and so then that's going to give you some kind of interesting, chaotic motion. And then typically you probably don't want a big radius. The looks are kind of deceiving. If you want a better way to kind of bring things in and push that around the actual torus shape or whatever. And let's turn this off real quick. you'll get much better results if the radius is smaller. So pretty interesting. But that's kind of the gist of the torus. It's kind of a weird thing. You probably don't need to use it much, but should you want very specific vortices or something like that, you can really force your simulation around that, and it's pretty neat. So the last force, which is definitely the best for last, and so let me go ahead and show you just a quick preset that uses this by default that ships with Embergen. I believe it's my little water example. Did it not ship with 1.2? I'm confused. Oh, here it is. Bubbling Swamp. And so this uses vorticles. So vorticles are by far the coolest thing inside of Embergen. It's the most powerful force that we have. And what it allows you to do is create localized vortices, not necessarily wherever you want, but for the most part, wherever you want. And so, for instance, right now we have these little vorticles spawning, and if we press M, we can hide my simulation. I can hide my ground as well, maybe hide my skybox. So we have these little dots popping up, and they're more or less a particle, and it's called a vorticle because it is a vortice that is attached to a particle, so it's a vorticle. So pretty interesting. And so, but the cool thing is that because they're particles, they can be advected and whatever else, and it's really cool. So, for instance, let's go ahead and create a new simulation, and we're going to kind of dive deep into vorticles because they're very advanced. But if you can get a grip on them, you can do some really cool things. So we'll turn off all of our other external forces just so that we can see what's happening only with our vorticles. And so now we've got our little vorticles, and by default, this is what they do. They fill the volume, and they're creating a lot of neat turbulence. If we turn those off again, you can see that the simulation is fairly smooth or whatever, minus the vorticity that's happening just naturally in the simulation as the time steps progress. And so, but we inject these vorticles, and it does something pretty neat to the sim. It acts kind of like a noise force, but a bit different because it's more localized, and where they're not present, nothing happens there. And so, kind of as the gist, you have a seed, so you can spawn vorticles in different locations, and it's a good way to, localize things or whatever, and kind of randomize your simulation. You can also increase your vorticles count. So if you want more chaos or whatever, you can have more vorticles. You can even have just one vorticle at a time if you want, and it'll do its thing and kind of, affect the simulation wherever it spawns. And so we can say have our little default of 50. And you also have a position. By default, the position doesn't necessarily matter when you're filling the volume, but it does matter if you have, say, a box. So in this case, we have a box of vorticles, and you can see that they are spawning within said box or whatever. And by default, their orientation is pointing upwards. And so we'll get there to in a second, but you can spawn, say, only on the surface of the box, only on the surface of the sphere, or say in a spiral or whatever. And this is really where your vorticles get crazy, and you can do all kinds of crazy shit, tornadoes, help build nebulas and all kinds of weird things, build like weird dragon shapes and whatever. And I'll show you that. So for instance, let's say that we have this spiral, we can increase our radius, and let's go ahead and maybe make, say 512 and max out our vortical. We're going to go to our position. We can change, say, our radius, and now we have vorticles spawning in a circle. And then we can have a height. And so that's going to create kind of a coil. So that's what the spiral is. It's more of a coil. And then we can also have revolution. So we can say, hey, I want you to rotate around 5 times. And so now we have this neat spiral shape. And then we also have pinching, which basically says, hey, I want my radius to go from my max all the way to 0 if we have 100%. And then we have some other controls like randomize position. So you can say, hey, I want it to be along that, but I also want to randomize where they are. Maybe we want to do it in the y-axis or something like that. So you can kind of change where these things are spawning. But why this is powerful is, let's go ahead and maybe make our radius a bit smaller, so that it goes like this, and maybe have a bit less revolutions. And then we're going to drag this into the simulation. And right now everything is really chaotic, and if we, hide these, you can see it's doing a pretty good job of making some pretty believable fire. We would need to, have some better shading and things like that, but for the most part, this is pretty believable as it is, and we have this cool system of vortices and things like that. And the way to read your vorticles, by the way, is where, if we pause this and let's maybe choose this one right here, where my mouse is. So you can see it's kind of like swooshing over this way. So basically this is going to rotate the smoke, and it looks like this is probably counterclockwise from our current direction. So it's going to do counterclockwise, and this one is rotating the smoke clockwise around this red axis. And then the red axis also means that there is possibly a push force. So you can also have a push along this. So it acts kind of like miniature line forces. And so now you can see that it's even crazier, because the vorticles are advecting in the simulation like particles, and they're pushing around and being completely chaotic. They're also doing a twist force. So if, say, we have no twist force at all, you can just see that now it's a bunch of little line forces pushing around in the simulation or whatever, and it's pretty crazy. And so we can do that. We can also have negative, so they can push and kind of pull around in the sim, and it goes pretty crazy. So very interesting. We'll just leave it to twist velocity for now. And so getting back to our positions, I kind of went over everything. If we turn off our advection, now they're going to stay only on that line that we have for the spiral. And then we'll move down to the orientation tab. If we have no orientation dampening, meaning trying to stop it from moving around chaotically, it's pretty cool, because you can have it be chaotic, or you can say, I want to maximize my dampening. And so now you can see that these vorticles, they're all pointing upwards, and they're all probably twisting in the same direction as well. And it's pretty interesting, because now we have an orientation type, which is just constant. You can also say shape aligned. So now they're going to be along this, kind of like as a tube. So it's going to be a tube of vorticity. And if we come in here to our sim and we change our force tightness like we were kind of taught to do, and maybe we make this say 100% or something like that, this is kind of going to follow that line, but not quite, because we're not pushing along it. So if we come here and we take our push force and we start to push this, and let's say we do this, now this is going to kind of push our simulation along this. I'm trying to figure out why it's not pushing the whole way. This used to work. Let's see, I need to think real quick. So we have our size, so we can kind of change the size of the vorticles as well. So maybe they just weren't big enough. And we also are affecting the sim quite a bit. So we've got our force tightness of none, of none, and then we've got it maxed out. And then if we view our vorticles here, they're kind of doing their thing. Maybe it's because it is affecting the whole sim. I'm trying to think, because there is a way to do this to where it's pretty cool. We might also have too many vorticles, so it's really affecting things quite a bit. And so there we go. So now it's kind of following the simulation. And do I have... Yeah, there is no masking on this. Sorry, I'm kind of confused just a little bit. But I would feel like this would kind of go up the pipe. Maybe I need to change the orientation to be... We used to have something called tertiary and secondary. And so, okay. Yeah, I guess this is right. But for some reason, it's not following the tube as much as I thought it would. But either way, if I figure it out, I'll upload a different video. And I'm probably going to have a whole video on vorticles as well, in general, because they're so deep, and maybe I'll have to dive into them a bit more. But overall, They're pretty neat because, like I said, you can push in certain directions. So if we go here and we've got our force, and actually I probably need to have everything pushing, and now change my force tightness, and maybe go here and change, say, my vorticity. Hmm, very odd, very odd. I don't know. It doesn't seem quite right. But anyway, so one of the cool things is, let's say that we choose a sphere. So now we have this little sphere shape, and we've got all of our little vorticles. And let's make our emitter a sphere as well. And so we can kind of come over here, and we're going to make this roughly in the same spot. So we'll say 12.5 there. We'll do 12.5 as our position for this. I'm going to make much larger bounds. And that could be the problem as well, is that maybe our bounds were too small. And so it's kind of doing the whole pressure thing. And so now we've got this, we've got our vorticles. And I'm going to go to my forces, and I'm just going to kind of do, say, 1 or whatever. And so now, basically, where these vorticles spawn, they're going to be pushing out our simulation away from this sphere with no chaos. But because our orientation is dampened, you can kind of see that we can do some weird things here. And so now we've got this kind of pushing. We can do some min and max. And we will go to our forces and do no tightness. And it looks like, things are acting kind of odd. It feels like it should push very far. Okay. Yeah, I don't know why this is behaving like this. It should be pushing this quite a lot. I feel like something is broken in Embergen right now. Hopefully another dev is on right now and can make a task. And I'm going to save this as a bug because this doesn't seem correct. I don't know what's happening here. I'm going to save this as a vortical bug. Such as the thing of a live training is sometimes there's some weird things that happen. Maybe we can make our sphere a bit bigger. And we're also only spawning on the surface, so maybe that's causing some oddities. I don't know. It's very odd. It just suddenly explodes. So maybe if we do some negative min. Very, very odd. I'll add some twisting in too. That kind of breaks it up. But this is kind of counterintuitive to what I wanted. Because basically what I want is, imagine, so let's go here. I'm going to delete my vorticles node and restart. Because what I want is, I want vorticles. Oh, wrong thing again. Okay, I'm panicking. All right, so force, we're going to do position 12.5, which is where my sphere is. And so now we kind of have like this little planet shape. And I will actually make my emission for fuel 0. We're going to max out my smoke rate. And so now we have just a big sphere. And we can see these vorticles kind of spawning in and creating cool little pockets of turbulence, which, by the way, this is one secret that I had for all of my cloud presets, is most of them use vorticles to create cool little pockets of turbulence and things like that. And while I'm here, you can increase the size of your vorticles as well. So if you want, larger sections of chaos or whatever, you can make the vorticles much bigger, and that's going to be pretty cool. You can also enable your force gizmo as well, to kind of see what they're doing, and maybe preview on a 2D grid to kind of see how they create their cool little things. And that gives you a better intuition of what's actually happening too with vorticles on slices and things like that. So pretty neat. But what I want to do is, I want to have this be a constant orientation. I want to say maybe point to the center, and this just doesn't seem like it's working right. For some reason, they're all pointing over here. They should be pointing to the thing. I think something with vorticles is just honestly kind of messed up, unfortunately. But maybe we'll do, say, a sphere here, and how How odd. Oh, I'm randomizing the position. That might be why. Yeah, you can see vorticals, they're quite complicated. Maybe there's a way for us to simplify all this. 'Cause it's quite a lot. Um, and so we want to go to our position. Now I feel like I'm fumbling. Okay. We'll do, say, a radius of like 12. And so now what this is doing, was the effect that I was trying to create. Maybe we just had them in too small of a radius and there was too many or something like that. I'm not entirely sure. What is the radius here? And we can also just, I wish I could plug that shape in for the vertical spawn, but looks like 7.6. We'll do 7.6, spawn these on the surface, and maybe have a bit less force. And so one thing is, if you want it to look kind of like a virus or a bulge or something like that, this is a cool way to do that, to kind of give you localized forces. This was my whole point that I was trying to get to, is that you can do some very interesting localized forces with these, because it's a bunch of little line forces. And it's also a good way to show that, say, like on a sphere or whatever, you could have, small time turbulence or whatever. So if you wanted to create something that's kind of like a planet or whatever, this might be an interesting way to do that, especially if you had this masked in like a collider or something, so that none of the smoke is escaping or whatever. Could be a pretty cool way to do things. So for instance, if I went over here and did like a collider, and we had a shape primitive, let's just say a box that's like 500 by 500 by 500, so it fills up the entire bounding box. And then we do a shape blend, and we do subtract, and we want to subtract out a sphere that's, I don't know, like 12 in radius. And then we do this, and then we hide our shape. And now we do, say, 12.5. So now we've kind of got a planet shape, and the smoke isn't going to escape that. We might need a smaller radius. Maybe we'll do like 5, 10, 8. Okay, there we go. That's about the surface. So we'll do 9. And so now we can kind of see a little bit of chaotic turbulence, and it's going to be locked in within this collider. So we can add in some bigger twist force or whatever it happens to be. And it'll be kind of a chaotic thing to fill up this shape. And we can probably add in more verticals as well. And so kind of a weird thing. We could do some twisting as well. And so now it's just going to be really, really quite odd. So kind of a cool way to do kind of a gas planet type thing in a weird way. And one thing you could do as well, since this is a collider, you can kind of see like all the voxels. One way to get away from that is to use masking shapes with your volume post-processing, but that's kind of a more advanced thing. And I'll have a tutorial on that as well. And so, by the way, within the next couple weeks, I'm going to be making a bunch of tutorials for YouTube finally, and we'll go over a lot of it. But overall, you can see that vorticals are a pretty interesting way to give us some really large shapes. You can do really large chaos, and basically they're particles, so they can be advected by the simulation with advection intensity. And if you just kind of come through here and play with this, you can kind of see that, main, it's just kind of saying how many vorticals you have and what their basic position is. Then you have the actual position where they're spawning, which is a sphere, a box, a line, a spiral. You can say whether or not to spawn on the surface, whether you want to randomize it, and then how much is being affected by the sim. And then you have your orientation dampening, which is, basically, am I going to allow them to be chaotic or not? And then what do I want them to do? Do I want them to have a constant orientation? Do I want it to be randomized or whatever it happens to be? Then you have the lifetime, so you can make them last, say, not as long if you really want a bunch of chaos in your sim. Then you have your twist thing. You have like a force attenuation as well, which is basically the fall off of the simulation. So if you want it to not have as much effect, you can have a high fall off. If you want it to have a very, very strong effect, you have a low fall off for your attenuation. And then you have your push and your pull, then your size, and that's pretty much it for verticals. And so to kind of show it in full on production or whatever, if you want to use it seriously, We have vorticles here that are very large, creating large vortices in my cloud. We could say increase the count so that they spawn a lot more. And this is going to give me a lot more crazy motion within my cloud. And let's say that I wanted even crazier motion from them. I could do, say, something like a push force. I could, really max out my twist strength or something like that. And now it's going to give me some pretty crazy growth in this cloud. Or whatever. So it's a great way to add chaos in specific areas, etc. So, if you wanted to do, maybe say something like a solar flare and you want to pull, your simulation around a certain area or something like that, that would be a cool way to do it with vorticles. So, and then the cool thing, like I said, is that these can be advected by your simulation. So, for instance, we have this ground fire, and we're using vorticles as one of the main turbulence influencers here. And we can say advect them more. We can increase our vorticles count, and it's going to make my fire crazier. And so without it, the fire looks fairly good, and it's already fairly chaotic and whatever because of like our force noise that's affecting the particles and whatever. But just by enabling these vorticles, it gives you a lot of really cool, dynamic motion, and you can see that they're just kind of wiggling around and doing their thing. And for the most part, I typically just leave it to field of volume, but you could do it, say, only on a sphere so that it spawns where the fire is, and then it travels with the fire and the flames and whatever. So it's pretty crazy. But it's just a really great way to add in just tons and tons of awesome details. So that's pretty much it. I ran over to about an hour. I didn't expect to go that far, but it's really quite unique. So kind of as a quick recap on everything, force noise is really great to be used to break up your emitter volume. So you've got your volume here. You can do something like this. Let's turn off my initial forces, and we'll say emission and fuel rate, and kind of bring this up here. So we've got this, and we've got this noise force. So it's a great way to break up your emission shapes and things like that. And this force is masked by the emitter shape. And then it's also the same thing as doing this. So plugging it in and then plugging this into the simulation is the same thing as plugging it into the emitter where it is. So because it's masked by the same shape. So it's going to give you the same results. It's just the difference is if you have a separate mask for this, you can move where the force is versus it being on the emitter, which is pretty cool. And so, yeah, so noise, great way to give you just general turbulence. You can use masking to your advantage to, say, only affect your fire. So in this case, right now, it's masked by the emitter, and it's only affecting where the fire is the hottest. So it's kind of a strength thing, which is really quite awesome. And then, yeah, just great for general turbulence. There is one setting called curl, and you can just kind of check it on and off. But more or less, like it says toggling this will generate curl noise rather than random noise. Curl noise has the property that it does not compress the fluid and work against natural movements. So basically, think of it as generating better vortices for you more naturally with the simulation versus just pure randomized chaotic noise or whatever. So kind of a cool thing to have that selector. And then with your line force, great for things like tornadoes because you can do twisting. It's great for pushing smoke or whatever in a certain way. So if I wanted to make wind on my fire here, I just kind of add this in to my force, and now it's going to push my fire, right? And so we want maybe a bit less push strength or whatever. We also learned that you can do a fall off. So if you don't want it to be as strong on everything, you can have a radius and only push the fire or whatever it happens to be within a certain radius and everything else. So really cool to kind of fake wind. And then with your point force, it's kind of an attractor. It's a great way to kind of come in here. And where is my gizmo? It's not showing up for some reason. also odd. I wonder if it's because I have so many different forces or something. Hmm, another bug. Um, I don't know what's happening there. Why I can't see the gizmo. So quite a few bugs today. But basically, allows you to, do some repelling strength and push away and do some pretty crazy things. So really, really quite awesome to use for the point force. And then finally, we have vector field, which basically, if you use our software Vector Raygen or even Houdini or whatever, you can generate a .fga vector field and load in a custom velocity field, which is what that does. And then we have our torus, which just kind of allows you to push and pull things. So you've got like your push strength, so we can kind of make this fire curl around or whatever it happens to be, twist it around an axis, kind of like a line force and so on and so forth, which is pretty pretty interesting. And you can see some of our rendering bugs there with our ground. So we can turn off our ground there and kind of fuck it. So, but then if you do that, then it doesn't stick to the ground anymore. So kind of a catch-22. But we're going to fix some of these rendering errors soon, by the way, especially some of the weird lines and stuff like that. We figured out kind of what it is, I believe, and that's going to be fixed soon. And so other than that, the last thing was the vorticals. So yeah, that's pretty much it. Are there any questions while I'm on here about forces or how you would do a particular thing, or maybe you're confused about something with a force? Are there any questions? And then just note that with your forces, you can mask your volume and your particles. You can only do your volume. You can only do your particles. So very, very powerful if you want to, which, yeah, maybe that's one last thing I'll show is, for instance, let's take this smoke shockwave because it's using particles. And then let's say that I want to make my particles only more chaotic. And so we can come here, do, say, a force, and we're going to do particles only. And I'm going to make this ridiculous, like 250. And so now only the particles are chaotic, and this force is not affecting our smoke. Whereas if it were affecting both, it would be too crazy and not even look good. So affecting only your particles is really, really awesome. So quite awesome. And so, yeah, hopefully you've kind of learned how to master forces. And if you go through a lot of our presets, you'll notice that I kind of have comments on each one. So this is like, turbulence, this is wind. And if you've bought our cloud pack, you can see if, you bring in any one of those, I'm saying like, hey, this is, large scale vorticity. This is turbulence. This is, a wind shear to push the cloud in a certain direction. Forces were used a lot in creating like my cirrus clouds. So using vorticals to really give me these large scale of custom vortices. If I bring in some different ones, say maybe like my particle based ones, they're using vorticals again to give me these cool curling shapes. They're affecting volume and particles, but I could have said, hey, I only want you to affect the particles or whatever, and then I want you to be stronger. So, for instance, if I came here, did particles only, and then maybe said a max strength of like 5 or something, it's really going to kind of pull those particles around and give me, more dynamic motion, but not affect the actual smoke as much or the cloud as much. But it will just a little bit because I probably have because it is like spawning the smoke or whatever, so it is going to kind of affect it. But you could say inject velocity from the particles as well, and that would give you a completely different cloud type. So really cool to come in here and play with all of these different clouds and whatever, which is quite cool. And you can just see all the different forces that I've used and how I kind of stack them up to get different shapes. So I've got like my line force, in a certain area, pushing the cloud. And then I've got, my vorticals kind of breaking things up in certain areas. And I've got my force noise, which has a bias in Y to kind of also push the cloud over here to the right. And then I've got, kind of a general noise, which is only affecting my particles. And so, we can change the scale of that if we want to. We can make it really small if we want to, or whatever, to kind of break up our shapes. And if you combine all these different noises together, it makes some really, really awesome clouds and stuff like that. And kind of the secret is just all this. So you can see by using this combination of forces, I was really able to honestly just sculpt this cloud. I'm like, hey, like I'm imagining that the wind is blowing mainly this way, but we have a little bit of extra wind blowing to the right. And then like I want some vortices, in the air. And then, what I want like a general force that's kind of, giving me some wispy bits on the end. And if I want wispy bits, then that means, I probably need to spawn from particles instead of a volume emitter. Because say if I spawned from a volume emitter, it'll probably look, quite good. Um, so let's see. So we've got this, and we'll say emission 0, smoke rate of 10 or whatever. And it looks fine, but it's not as wispy and dynamic or whatever as our cloud was. And let me maybe say, do just like a box, and we'll make it really thin, and we'll just expand it wide to kind of mimic it. So you can see it is interesting what it does, but the particles really give you a much, much better shape. And it's all dynamic and random and gives you some cool. So pretty interesting. Um, yeah, I think that's about it on forces, guys. That's pretty much it. So hope you learned a lot. I hope this helps you out in crafting, explosive simulations. Helping you generate better turbulence in your fire, helping you understand what your forces are doing. Really go in and use your gizmos to kind of come in and show you what's happening with things. Remember that you can do a 2D grid as well. And so now with this, you can really visualize what's truly happening with your forces and things like that. So really quite awesome. And also dive into vorticles. I mean, vorticles, they are so powerful. It looks like we have maybe a couple of bugs in it right this second that maybe we'll have to investigate a little bit, especially if the vorticles are close. It seems like the simulation doesn't want to move with that. But for the most part, I mean, it's awesome. There's so many cool things you can do with them, and they're honestly one of the best ways to get some pretty crazy turbulence and things like that in your sim. And then you just utilize this kind of stuff where also remember that you can plug in multiple noise forces to stack those on top of each other. So not only can you do octaves, but you can have 4, 5, 6 different noise forces, all with different masks, or apply it in different areas if you have a mask shape. So maybe you want a certain level of force on the right side of the sim, and then you want a certain level of force on the left side of the sim, or whatever. There's so many crazy, awesome things you can do. And then, remember that particles themselves can be a force as well. So, for instance, with, say, these explosions, we get a lot of these crazy, cool tendrils just solely because we're injecting a lot of force over the life of the particle, which is really awesome. And you can use emitters as forces as well with, say, pressure. For instance, so if I don't have pressure at all, we just have this really basic high velocity sim, but you kind of come in and you add more pressure, and that's going to give you quite a bit more smoke and fire and whatever. So really quite awesome. And then you come in here and you can kind of debug, everything to see what it does. You take your 2D grid and you kind of see what your velocity channel is looking like. And so just imagine, the best way to be intuitive about these forces is, try to think about what you want your sim to do, and then use your forces to craft the shapes that you want. And that's really kind of the secret behind building anything you want in Embergen. And so forces are an integral part of pretty much everything in Embergen. And hopefully I'll have a much more concise tutorial set for these forces and stuff like that in the future with my series that I'm going to create called Simtuition, which is I'm going to teach you the basics of how the simulation works, which is pretty cool. And Daniel, I will let you speak in just a second. Here we go. What do you got to say, Daniel?
Oh, I just figured that I had a pretty cool composite to show.
Sure. Let's see it.
All right.
Stop my stream.
Ah, yeah.
So Daniel is one of our effects artists on the team. He does a lot of the cool.
Yeah.
He did like the torch tutorial, the like bomb tutorial that we have, and then like all the nuke workflow and everything like that. So
It should be it. Yes. So I've been working on this crater thing for a bit, and I figured it might be interesting to look at this comp because I think it turned out pretty well. Mm. So just some just kind of what our capture types can do, because we can export the shadow paths, for example, from Embergen, which you can use in compositing, and this path called scattering shapes. It came out like this, and then I did a lot of blurring on it. Often when you have glowy stuff, I tend to use a sequence of blurs, like and then slightly bigger, and then I mix them down a bit. And for the smoke, something interesting is that we have these passes called 6-point lighting. So here I use the 6-point lighting to mask out the bottom of the smoke to, let's see how apparent it is. Yeah, barely. But what you can do is, for example, if it was a green grassy ground, you could just sort of turn the green up there and then have this sort of fake global illumination type thing. So some light trapping over here.
I wonder if we
Yeah,
could ever release some nuke projects or something like
yeah,
that for anybody who uses nuke.
yeah,
That
yeah.
could
Because
probably
there's
be pretty cool.
I do feel like I'm sort of still figuring stuff out, but there's just uh, particular tricks that I tend to use a lot, because there's a certain way we export stuff, right? There's somewhat of not too much, but there's somewhat of a look of the things we output. So there's specific tricks that work well with our renders, I feel like. For example, the this thingy where I have the fire. Like here, it looks very monochrome, or like one color. And well, what you can do to get this reddish tone you often get in fire. It's a bit of a trippy one, but there's a reference where in the darker tones it goes more red. Um, what I do is shuffle the red channel into the alpha, then impromote it, and then just shift the lift around. Bit of an odd technique, so I thought it might be interesting to show. And then you get this very nice red, uh, darker tones in there. So yeah, I won't do like a some long compositing tutorial, but I just thought that might be interesting to show,
Yeah.
because yeah, it
Awesome.
good
Awesome
compositing
project.
adds a lot, of course, to having good effects.
Absolutely. So thank you.
Yes,
All right.
I'll leave the stage.
I was gonna say I'll kick you from the stage for a
Yeah,
second. So basically, I believe that's pretty much it. And maybe one day we could have Daniel, because we might do more of these events here in Discord, and maybe we'll do them, maybe once a month or something, and we could do like a nuke, intro to nuke comping with Embergen, and maybe provide some projects or something like that for people to follow along, and that kind of thing. And I kind of want to explore this format overall. Does anybody have any feedback about the format? What do you think about how this was? I learned that maybe I could be slightly more prepared, maybe with some preset projects or something to kind of go over the noise. But for the most part, I think we did pretty good within the hour that we were here. Good, good. And this will also be on YouTube as well, in case you missed anything or you want to see how I did something or whatever. So yeah. All right. Well, I'll see you guys later, and feel free to chat in like the Embergen live stream channel if you have any more questions or whatever. And we're always here to help. So yeah, we'll probably schedule another thing within the next couple weeks. Maybe I'll do one on fire or something like that, because I'm going to be diving in and making a bunch of premium fire presets. So will probably be a good time for me to teach how to do it from scratch yourself as well. So pretty neat. So cool things coming, and keep an eye out for a bunch of tutorials. And also Jesse, I guess you say his name, Tella, I don't know, from Redefine Effects. He created a big course recently too, and I can vouch for it and say that it is quite awesome. So go check that out. It's in the lounge if you're interested in learning more from an Embergen master. So lots of cool stuff from him as well, which is awesome. So I'll catch you guys later, and thanks for joining me. This will be on YouTube soon. Bye for now.